Hey everyone, and welcome back for another deep dive. This time, we're going deep into the world of distributed tracing tools.
Ooh, exciting.
It is exciting. These tools are kind of like a detective's magnifying glass, but for software.
I like that.
I know, you're helping us understand these complex systems that are out there.
Right.
And we've got a ton of resources to dig into.
Ah, cool.
We've got some academic papers, of course. We've got some cloud provider documentation.
Mm-hmm.
We even found a head-to-head comparison of some popular tools.
Awesome.
But we're not just going to be like, reading spec sheets.
Right.
We want to go a little bit deeper.
Yeah.
We want to understand why.
The why.
Yeah. Why should anyone building or using modern software care about this stuff?
Yeah, that's a great question. I think with, all these microservices and cloud-based architectures, it's really hard to understand like how our request actually travels through a system.
Totally.
It's a huge mess.
Yeah.
And so distributed tracing is kind of like that map to like, all right, follow along this path. Yeah.
And see where things either slow down or break down or just get lost.
So it's not just about fixing bugs, but actually understanding the flow.
Yeah.
How would you even explain distributed tracing to someone who's never heard of it before? Like, what's the core concept?
So imagine like a detective, right?
Yeah.
Following clues across a city.
Okay.
And each stop, each witness, each clue is kind of giving you a piece of the puzzle, right?
Mm-hmm.
So in software, that trail is what we call a trace.
Mm-hmm.
And that's the entire journey of a user request through your system, right?
Yeah.
And then each one of those clues is what we call a span,
Gotcha.
which is like a specific step. So it might be a database query or a call to another service or just doing some computation.
Okay, so the trace is the route, and then the spans are each little, like, turn or stop along the way.
Exactly.
Gotcha. Okay.
Yeah.
So why is this so important in, like, the world of software that we have today?
Well, I mean, things are never as simple as they seem, right?
A user clicks a button, and behind the scenes, there could be, like, hundreds of actions happening.
Yeah.
And then if something goes wrong or if things slow down, it can be a real nightmare to figure out what's going on.
Right.
So distributed tracing gives you that like granular view, right? To see exactly where the bottlenecks are, where those errors are happening,
Yeah.
and ultimately how to optimize performance for your users.
So it's almost like having X-ray vision into like the inner workings of your software.
Yeah.
Okay, so I'm starting to see why this is pretty valuable.
Yeah.
But like, where did it all begin? I feel like I've heard of like some groundbreaking Google paper that laid the foundation for all this.
Yeah, you're thinking of the Dapper paper,
Dapper, okay.
which was published back in 2010, and it really was a game changer.
Okay.
I mean, the Google team, they were dealing with these massive systems, right?
Right.
And they needed a way to understand how they were performing, but the traditional monitoring tools, they just weren't cutting it.
So they decided to build their own.
They did, yeah.
Wow, okay, that's ambitious.
It was.
I can't even imagine, like, what were some of the challenges they had to face?
Well, I mean, first of all, they had to make sure that tracing itself didn't become a bottleneck, right?
Sure.
So the overhead had to be super minimal, almost invisible to the applications.
Oh, okay.
Second, they wanted it to be easy for developers to actually adopt,
Right.
because nobody wants to write a ton of instrumentation code.
Yeah, that's the worst.
And finally, they needed a way to continuously monitor all their systems. And remember, Google is massive.
Yeah.
So they had to figure out a way to not drown in all the data.
Okay, so it sounds like they were trying to strike like this delicate balance between power and efficiency.
Right.
So did they actually manage to pull it off?
They did. And it was pretty amazing, actually.
Okay.
So they came up with this 3-stage pipeline for collecting all that data.
Okay.
First, local logging within each component. Then a daemon, which collects that data and sends it to a central repository. And finally, they stored it all in Bigtable, which is their distributed database.
Yeah.
And they were able to collect all that data incredibly fast, actually.
Right.
Yeah, like a median latency of under 15 seconds.
Wow, under 15 seconds for all of that.
Yeah,
That's impressive.
it is.
But you mentioned that they were worried about like drowning in data.
Yeah.
How did they prevent that?
So that's where sampling comes in.
Yep.
Instead of collecting every single trace, they decided to only capture a fraction of them.
Right.
So it's a bit of a trade-off, right?
Well,
You lose some of that granularity,
yeah.
but you gain manageable storage and processing.
So it's like a necessary evil, I guess.
Yeah, pretty much.
So once they had all this data, how did people actually access it and use it?
Yeah, so they created the Dapper Depot API or DEET API to let developers interact with all that trace data.
Okay.
And there were multiple ways to access it depending on what you were looking for.
Okay.
You could search by a specific trace ID. You could analyze like massive data sets using MapReduce,
Oh, wow.
or even use an index search.
Okay.
So it gave them like a really flexible toolkit.
Wow, so it sounds like Dapper really was like the spark that ignited this whole distributed tracing world.
It definitely played a huge role,
Yeah,
but it didn't end there.
of course not.
As more people started working on this problem, they brought their own ideas and their own approaches.
Right.
And so you had all these different tracing systems emerging,
Okay.
and they were all doing things a little bit differently.
Ah, so it was like too many cooks in the kitchen.
Exactly.
Okay, yeah, I can see how that would get messy.
It did, yeah.
So what happened next?
Well, that's where the need for standardization became really apparent.
Right.
Developers were getting frustrated trying to switch between tools
Yeah, totally.
or integrate them into their existing systems.
Yeah.
Something had to change.
Okay, so how did the industry respond? Did they manage to wrangle all these tools into something more organized?
Well, they did, but it was a long road, and it's actually where open tracing comes into the picture.
Open tracing, okay.
Yeah, and that was an attempt to create a common language
Okay.
so that all these different tracing systems could talk to each other.
So it's like a universal translator for tracing.
Exactly.
I like it. So tell me more about open tracing. Like, what impact did it have?
I mean, it was a huge step forward, for sure,
Mhm.
but it was really just the beginning of this journey towards interoperability and standardization.
Okay.
And to really understand where we are today, we need to trace that evolutionary path.
I'm intrigued. So let's continue this exploration in part 2 of our deep dive.
Sounds good.
We'll unpack how tracing standards evolved and how we went from this jumble of tools to a more unified and powerful ecosystem.
I'm looking forward to it.
See you in part 2.
See you there.
All right, welcome back to our deep dive into distributed tracing. Last time we talked about how things got a little messy with all these different tracing systems popping up.
Yeah, it was a bit of a Wild West out there.
Total Wild West. But then open tracing came along, trying to bring some order to the chaos.
Right, trying to establish that common language, so to speak.
Exactly. So different tools and systems could at least understand each other.
It was a big relief for developers, that's for sure.
Oh, yeah, I bet. So what were like the key things that open tracing focused on?
Well, they really nailed the basics, like span management.
Go.
They standardized how data is transferred between systems, and they made sure it worked across different programming languages.
So developers could instrument their applications once and then choose from a variety of tools.
Exactly. It gave them more freedom and flexibility.
That's awesome. So was open tracing like the final solution then? Or did things keep evolving?
Well, it was a huge step in the right direction.
Okay.
But as systems got more complex, people started realizing that tracing was just one piece of the puzzle.
Oh, okay. So what were they missing?
Well, think about it. You've got tracing showing you the path of a request.
Right.
But what about metrics? What about logs?
Huh.
All of these things are important for understanding the health and performance of a system.
So it's like having different specialists examining a patient.
Yeah, exactly.
You need all of their insights to get the full picture.
Right, and that's where OpenCensus came in.
OpenCensus. Okay.
It built on open tracing, but it also brought metrics into the mix.
Gotcha.
So now you could see not just the path of the request, but also things like resource utilization, error rates, all that good stuff.
Okay. So OpenCensus was like adding more instruments to the orchestra.
I like that analogy, yeah.
So we've got open tracing and OpenCensus both trying to bring some order to the tracing world.
Right.
But wasn't there still some overlap between the two?
Yeah, and that's where things start to get a little, well, complicated again.
So back to square one.
Not quite. But the industry realized that having two separate standards, even with some overlap, wasn't ideal.
Yeah, makes sense.
They needed something that would truly unify everything.
All right, drum roll, please.
Enter.
OpenTelemetry. OpenTelemetry, the hero of our story.
Pretty much, yeah.
Okay, so tell me, what makes OpenTelemetry so special?
Well, it's basically the culmination of everything that came before it.
All right.
It took the best of open tracing and OpenCensus and merged them into a single, powerful standard.
So it's like finally getting all those specialists to work together as a team.
Exactly. Now you have tracing, metrics, and logs all under one roof.
And everyone's speaking the same language.
Precisely. And that's huge for observability.
So OpenTelemetry is like the gold standard now.
You could say that, yeah.
Okay. And what are some of the benefits of using it?
Well, first of all, it's vendor neutral.
Okay.
So you're not locked into any specific provider.
Gotcha.
It also provides a standardized way to instrument your applications.
Mm-hmm.
And perhaps most importantly, it allows you to correlate data from all those different observability signals.
So you can get a much deeper understanding of your system.
Exactly.
It sounds like OpenTelemetry was a real game changer.
It was, yeah.
But even with a unified standard, I imagine there are still a ton of different tracing tools out there.
Oh, absolutely.
So how do you even begin to choose the right one?
Wow, that's a great question, and it really depends on your specific needs and priorities.
Okay, so it's not a one-size-fits-all situation.
Definitely not.
What are some of the things you should consider when evaluating these tools?
Well, first you need to think about the scale and complexity of your systems.
Right.
Are you dealing with a handful of microservices or a massive ecosystem with hundreds of interconnected components?
Okay, so different tools might be better suited for different sizes of systems.
Exactly. Some are great for handling tons of data, while others are more lightweight.
Makes sense. What else should you keep in mind?
Integration is super important.
Integration, okay.
How easily does the tool fit into your existing workflows and tools?
Right.
You don't want to spend hours trying to make things work together. Absolutely. You want something that plays nicely with your programming languages, your deployment environments, all of that.
So compatibility and ease of use are key.
They are, for sure.
Anything else?
Of course, you also need to consider the features and capabilities of the tool.
Right.
Does it offer what you need?
Yeah, like what kind of visualizations does it provide?
Exactly. Or does it have real-time monitoring?
Or advanced analytics.
Yeah, all of those things.
So it's like choosing between a Swiss Army knife and a specialized toolkit.
That's a good way to put it.
You need to decide what's best for your particular situation.
Right.
And what about cost? Is that a big factor?
Definitely can be.
Yeah.
You've got open source solutions that are free to use,
Okay.
but they might not have all the bells and whistles.
Right.
And then you have enterprise-grade platforms that can be quite expensive.
So you have to weigh the value the tool provides against your budget.
Exactly. It's all about finding that sweet spot.
So it sounds like choosing a distributed tracing tool is a pretty complex decision.
It can be, yeah.
But wouldn't it be helpful to hear from people who have actually used these tools in the real world?
Oh, absolutely.
Like, what are their experiences? What are the pros and cons?
That's what we'll be diving into in the next part of our deep dive.
Okay, awesome. So in part 3, we'll be talking to some practitioners
We will.
and getting their insights on what works and what doesn't.
I can't wait to hear what they have to say.
Me too. All right, see you in part 3.
See you there.
Welcome back to the final part of our deep dive into distributed tracing. So we've gone through the basics, talked about standards, even looked at some of the tools.
Yeah, we've covered a lot of ground.
We have, but as you've mentioned before, picking the right tool, well, that's just the first step.
It is, yeah, because at the end of the day, a tool is only as good as its usability.
Usability. Okay.
Yeah, how easy it is for developers to actually use it effectively.
So it's not just about having all the fancy features, it's about whether people can actually use them.
Exactly. You can have the most powerful tool in the world, but if it's clunky and confusing, it's just going to slow people down.
So like having a sports car, but not knowing how to drive stick shift.
Yeah, kind of like that.
Okay, so let's talk about usability then. What are some of the things that make a distributed tracing tool user-friendly?
Well, one of the biggest things is complexity.
Complexity.
Some tools are incredibly powerful. They have tons of features and customization options, but that can also make them overwhelming, especially for new users.
Right, so it's a trade-off.
It is. You have to find that balance between power and simplicity.
So which tools did you find were particularly good or bad in this area?
Well, AppDynamics, for example.
Yeah.
It's known for being very comprehensive,
Okay.
but that also means it has a pretty steep learning curve.
So it might not be the best choice for smaller teams or beginners.
Probably not, yeah, unless they're willing to invest the time and effort to learn it.
Okay, what about tools that were more user-friendly?
Well, Datadog stands out.
Datadog.
They've really focused on usability testing. They listen to their users and try to make their features as intuitive as possible.
So it's not just about having a pretty interface, it's about understanding how developers actually work.
Exactly.
Were there any other tools that stood out in terms of usability?
Yeah, Dynatrace is another one.
Dynatrace, okay.
They've done a lot to simplify performance management, especially in DevOps environments.
Like how?
Well, they have features like automated performance analysis,
Mm-hmm.
and their troubleshooting tools are really intuitive.
So it's like having a co-pilot who can help you figure things out.
Exactly.
That's pretty cool.
Yeah, and then you have tools like New Relic, Sentry, and Splunk.
Okay.
They all prioritize performance and management.
So they try to stay out of your way and let you focus on your work.
Exactly.
So we've talked about complexity, but what about error resolution?
Yeah, that's another big one.
Like, how easy is it to figure out what went wrong and fix it?
Right, because nobody wants to spend hours digging through logs.
No, definitely not.
So some tools are better at this than others.
Okay, like which ones?
Well, New Relic, for example,
Yeah.
they got some feedback that their error handling workflows could be improved.
Oh, okay, so it wasn't as straightforward as it could be.
Right, developers felt like they were spending too much time trying to pinpoint the root cause.
What about OpenTelemetry?
Well, OpenTelemetry is great in a lot of ways,
Hmm.
but it can also be a bit challenging to learn,
Okay,
especially when it comes to environment support and health management.
so it might not be the best choice for beginners.
It depends, yeah.
Okay, what about Sentry?
So Sentry is known for its error tracking
Right.
capabilities, but even they got some feedback that their error resolution processes could be streamlined.
So there's always room for improvement.
There is, always.
Okay, so we've covered complexity, we've covered error resolution. What about just the overall learning curve? Like, how easy are these tools to get started with?
Yeah, that's a good question.
Especially for someone who's new to distributed tracing.
Right, so some tools are definitely easier to pick up than others.
Okay, like which ones?
Datadog and Dynatrace, for example,
Okay.
they have really intuitive interfaces, great documentation, and helpful tutorials.
So they make it easy to get up and running quickly.
They do, yeah, but then you have tools like AppDynamics and OpenTelemetry.
Hmm.
They're powerful, but they can also be quite complex.
So it takes more time and effort to learn them.
It does, yeah.
So it's kind of like choosing between a beginner ski slope and a double black diamond.
Exactly.
You need to know your limits.
That's right.
Well, this has been a fascinating deep dive.
It has, yeah.
I feel like I've learned so much about distributed tracing.
Me too.
So, any final thoughts for our listeners as they start exploring this world?
I think the most important thing is to do your research.
Okay.
Understand your needs, your priorities, your team's skills,
Right.
and don't be afraid to experiment.
So try out a few different tools before you commit to one.
Exactly. Find what works best for you.
Great advice. Well, thank you so much for sharing your expertise with us.
It's been my pleasure.
And to our listeners, thank you for joining us on this deep dive into distributed tracing. We'll see you next time as we explore another corner of the tech world.